Hi, this is Jeff Spence, your Math 135 instructor for the Community College of Denver. I'm on to doing some examples from 6.2, some binomial examples. You can look back at these at any time in preparation for the test, doing your classwork, or whatever, preparation for the final. So, in binomial examples, we have to have a binomial situation. So, in every binomial situation, we better have an n, which is the number of trials, a p, which is the probability of success, and an x, which is the number of successes out of n. So if we say, suppose Spence is late to work 82% of the time. We observe 10 random days and record the number of times that Spence is late. So remember, the number of times I can be late to work, if you observe me 10 random days, is anywhere from 0 to 10. Yes? Okay. That means that if you're going to observe me for 10 random days, the number of trials is 10. The probability that, now this is where success is not the best word, but the probability that I am observed as being late, which in this case we'll consider a success, is 82%. Now x depends on the problem, and that's what A, B, and C are about. Okay? So, we're going to answer these depending on the question, or figure out what x is depending on the question. So A asks, give the probability that Spence is exactly 6 days late. This means that that means that x is 6. Now the n and the p are the same. So we still observe 10 days, and the probability that I'm late is 82%. So for this problem, we're going to do the binom PDF from our calculators. Remember, second vars. And then we put in n, which is 10, p, which is 0.82, and then x. In this case, it's 6. You plug that into your calculator. Let me do it quickly. Binom PDF of 10, 0.82, 6. Enter, and we get 0.0670. About a 6.7% chance that I'll show up exactly 6 days late. Next question. This asks for exactly 9 days late. So this means that x equals 9. So once again, we do the binom PDF of 10, which is still n is still 10. 0.82 has not changed, and x 0.82, and x is now 9. Plug that in. Binom PDF of 10, 0.82, 9, enter, and we get 0.3017. Gosh, this is hard to write sometimes on this. 3017. So about a 30% chance that I'll show up exactly 9 days late, or late 9 days. Okay, last one for this page. What about the probability that I show up exactly 2 days on time? Well, this is interesting. So now I'm asking about on time. There's an 82% chance that I show up late, but what about showing up 2 days on time? Well, there's two ways to do this. The first one would be this. I would call x2, but I would have to change my p, because now we're asking about the probability of on time. So what I would do is I'd say, well, if he's late 82% of the time, he's on time 18% of the time. And so I would do the binom PDF. N is still 10. We're still looking for 10 days. The probability of being on time is 18%, and then 2 days on time. So distribution binom PDF 10, 0.18, 2. And that's 0.2980. However, another way to do this is, instead of changing the p, you could change the x. If I'm on time 2 days, how many days does that mean that I'm late? If I'm on time 2 days, that means that I'm late 8 days. So you could do the binom PDF of 10.82, that's the late, percentage of being late, gosh, that looks terrible, 0.82. And then, since 2 days on time means 8 days late, it'll be the same answer, 0.2980. So these are basic questions using the Binompdf. On the next page, I'm going to show you how to use the Binompdf to get intervals of answers. And this is going to be really interesting. This is the one that you're really going to want to check out. Actually, I'm going to do a whole new recording. So